So now we're going to look at the F3 assignment, and the focus is on the least squares regression line. So our first question is, what is the least squares regression line? Is it the line that makes the square of the correlation and the data as large as possible, the line that makes the sums of the squares of the vertical distances of the data points from the line as small as possible, the line that splits the data in half with half the points above the line and half below the line, or all of the above? So I'm going to use an applet to explore this. So the point of a least squares regression line is you're trying to pick the line that makes these squares as small as possible. So you can see here's the sum of the squares. There it's 7.7, there it's 12. So I tried to adjust this. Actually, didn't we have 7 down here somewhere? Here we go, 7.7. And then maybe I can adjust a little better here. 719. And so what you're trying to do is minimize these squares. There we go. And hopefully if you minimize it properly, it'll probably take a couple of adjustments every time, trying to get that best. You'll actually get close to the actual regression line. And you can see if I drag right here, I actually get under 6 for the area of the squares. So the point of a least squares regression line is to make these squares here as small as possible. And how do we make the squares? It's the vertical distance from the point to the line, the regression line, and you just square it. So you can see that we don't necessarily have half the points above or half below, although in this case it looks like we have 3 points below here and 2 points above. So that doesn't, C is not an option. And we're definitely not trying to make the square of the correlation. Well, you can have the square of the correlation as large as possible, but that's not the point of the least squares regression line. The answer is B, the line that makes the sum of the squares of the vertical distances of the data points from the line as small as possible. Hint, it says least squares, smallest possible squares. Number 2, when possible, the best way to establish that an observed association is a result of a cause and effect relationship is by means of what? So you might be tempted to say, oh, it's a least squares line. No. Cause and effect we only determine with random assignment in a well-designed experiment. So even though this is the assignment with least squares line, that doesn't mean that's automatically the correct answer. Number 3, a researcher wishes to study the average weight in kilograms of children and changes during the first year of life. He plots these averages versus the age in months and decides to fit a least squares regression line to the data with X as the explanatory variable and Y as a response variable. He computes the following quantities. R is 0.9, the mean of X is 6.5, and the mean of Y is 6.6. The standard deviation of X is 3.6, and for Y it's 1.2. So then they ask you what the slope is. So you have this formula on the front page of your math chart, the one that you get to use on your AP exam and every one of mine. So we know R, let me go ahead and get this. We know R, that's 0.9. We know the standard deviation of Y is 1.2, and S of X is 3.6. So we just substitute in, and we get 0.30. So the slope of the least squares regression line is 0.30. So that's it. Basically, make sure you know this formula. It's in the front of your math chart. Consider n pairs of numbers. Suppose that the mean of X is 4, the standard deviation of X is 3, the mean of Y is 2, and the standard deviation of Y is 5. Of the following, which could be the least squares line? So we're going to go back to that formula we just used, and that is B equals R times the standard deviation of Y divided by the standard deviation of X. So I'm going to substitute. Now you're going, wait a second, you don't know R. You're right, I don't. So let's continue anyways. So B is R times 5/3. So that means the smallest this could be, R could be from -1 to +1. So that means B can be anywhere from -5/3 to +5/3. So a slope of 2 is bigger than +5/3, and a slope of 3 is bigger than +5/3. We also know that the point has to pass through the line of both means. So it has to pass through 4, 2. So I'll go ahead and substitute those values in the other 3 lines. And which of these work? 2 equals 2 plus 4 does not work. 5/3 minus 4 does not give me 2, but 6 minus 4 does. So my answer is E. In a study of 1991 model cars, a researcher found that the fraction of the variation in the price of cars that was explained by the least squares regression on horsepower was about 0.64. For the cars in this study, the correlation between the price of a car and horsepower is found to be positive. The actual value of the correlation is what? So we know r squared is 0.64, and r is plus or minus the square root of 0.64, or basically plus or minus 0.80. Now they told you it was positive, so we'll say it is positive 0.80. Now if you need the slope, remember that r has to match the sign of the slope. So that's how you could narrow it down when you have this plus minus. Okay, the correlation between x and the y in the graph shown is negative 0.928. Suppose we add another point at the location marked x. What would be the impact on the slope and the intercept? So let's play with it. So if you click on the link on this problem, it will bring you to this applet, and it allows you to basically add points, and you can approximate a regression. So I'm trying to roughly draw what you're seeing on your problem right here. So it'll show you the least squares regression line. You can see things like the residuals, and you can show the mean x and y. So we're adding a point. Now, the reason we do want the mean x and y is we're actually adding a point. Actually, one of these is supposed to be a little bit lower. And let's see, that probably needs to be a little bit higher. That maybe a little further out. Just trying to match it up pretty close. There we go. And then they ask you, what happens if you add a point somewhere out here? What happens to the slope? So if I go ahead and click an X here, you can see this is going from here to here. What it does is, if you click on it, you can take it off, and then you can put it back. So it seems to be lowering the intercept. So let me do that again so you can see where the intercept is. So you have the intercept lowered, and then look at the slope. The slope is less negative. So the slope is increasing. So, oops, let me go back. So that tells you that the intercept will decrease and the slope will increase. The answer is C. Number 7, there are 8,253 men and 10,327 women at a state university. If 43% of the men and 27% of the women are business majors, what is the expected number of business majors in a random sample of 200 students? So you know we're going to mix all these men and women. So probably the easiest thing to do is find the total number of business majors. And we know 43% of the 8,253 women and 27 of the 8,253 men, and 27% of the 10,327 women are business majors. I get about 6,337 business majors. So then if I go ahead and divide it, 637 divided by the total number of students, I get the proportion of business majors is 0.341. I know my sample size is 200, so my mean or expected value is the number of the sample size times the proportion, 200 times 0.341, or 68.2. So that's your answer. Suppose that the correlation is negative given 2 points from the scatter plot. Which of the following is possible? So what I've done first is I've gone ahead and used that same applet I showed you earlier. And I said, well, let me go ahead and draw sort of a scatter here where I have a negative correlation and see if I can figure out if I can make these scenarios true. The first point has a larger x value and a smaller y. Well, these two count. So this is a larger x, but a smaller y. All right. I could have the first point has a larger x, but a larger y. Okay, those two. See, this is a larger X and a larger Y. The first point has a smaller X and a larger Y. Well, that's actually technically, oh wait, this one, the first part, yeah, that's the same thing as a smaller X and a larger Y value. That's the same as this scenario right here. Let's see if I get my pointer so you can see it. So this has a smaller X but a larger Y than the second point. So since I was able to make all three statements true, and it says possible, it doesn't say has to be true, it just says possible. All of these are possible. So the correct answer is E. Bias in a sampling method is, okay, this is a definition. I've seen you miss this on your tests. Bias is a tendency to overestimate consistently or underestimate consistently, depending on the scenario, when using a particular methodology. So if you use one methodology, for example, if I ask students if they wash their hands when they go to the bathroom after using the bathroom, and I ask them to their face, I consistently get an overestimate of the true percentage who actually wash your hands, right? So that is a bias because that I'm experiencing, it's response bias, and it is causing an overestimation of the percentage of people who wash their hands when using the bathroom. So any difference between the sample result and the truth about the population that tends to occur in the same direction consistently whenever you use this sampling method. Number 10, you wonder if TV ads are more effective when they are longer or repeated more often or both. So you design an experiment. You prepare 30-second and 60-second ads for a camera. Your subjects all watch the same TV program, but you assign them at random to 4 groups. One group sees the 30-second ad once during the program, another sees it 3 times, the third group sees the 60-second ad once, and the last group sees the 60-second ad 3 times. You ask all subjects how likely they are to buy the camera. Which of the following best describes the design of this experiment? So, first of all, there are no pairs or blocks. This is just completely randomized. So it's either C, D, or E. So we just have to figure out how many factors there are. Well, one of the factors is the length of the ads. It's either 30 or 60 seconds. And then the second factor is the frequency of the ads. Do they see it once or do they see it 3 times? So this is a completely randomized design with 2 explanatory variables or factors. Number 11, the sales force for a publishing company is constantly on the road trying to sell books. As a result, each salesperson accumulates many travel-related expenses that he or she charges to a company-issued credit card. To prevent fraud, management hires an outside company to audit a sample of these expenses. For each salesperson, the auditor prints out the credit card statements for the entire year. Then he randomly chooses one of the first 20 expenses to examine and then examines every 20th expense from that point on. Which type of sampling method is the auditor using for each person? So most of you probably are never going to watch this video because you're like, oh, this is easy. When you pick a random starting point and then go every like 20th or nth, that is systematic random sampling. So one of the easiest methods to keep straight. Number 12, researchers randomly selected 1,700 people from Canada who had never suffered a heart attack and rated the happiness of each person. 10 years later, the researchers followed up with each person and found that the people who were initially rated as happy were less likely to have a heart problem. Which of the following is the most appropriate conclusion based on this study? Well, this is an observational study. We didn't make them do anything, so we can't say causes. So that eliminates choices A, D, and E. Now, we can also, these are people selected from across Canada, so we can actually infer to the Canadian population. So we can say happier people in Canada are less likely to have heart problems. If we had had volunteers in this study, then it would have been happier people in the study were less likely to have heart problems. But we didn't have volunteers. We randomly sampled from the Canadian population, so we can infer to the Canadian population. Number 13, Can texting make you healthier? Researchers randomly assigned 700 Australian adults to either receive usual health care or usual health care plus automated text messages with positive messages such as, walking is cheap. It can be done almost anywhere. All you need is comfortable shoes and clothing. The group that received the text messages showed a statistically significant increase in physical activity. What is the meaning of statistically significant in this context? All right. So first of all, what does statistically significant mean in any context? It means that the differences are bigger than what we would expect by chance if the two groups were the same or the multiple groups were the same. In this case, we also add physical activity. So we say the difference in physical activity for the two groups is larger than the difference that could be expected to happen by chance alone. Number 14. You want to know the opinions of American high school teachers on the issue of establishing a national proficiency test as a prerequisite for graduation from high school. You obtain a list of all high school teachers belonging to the NEA, the National Education Association, which is a country's largest teachers union. And you mail a survey to a random sample of 2,500 teachers. In all, 1,347 of the teachers returned the survey. Of those who responded, 32% say that they favor some kind of national proficiency test. Which of the following statements about this situation is true? So first of all, we do have a very low response rate. We have 32% of the people we surveyed actually responded. So we have some non-response bias in here. Additionally, members of the NEA are probably less in favor of national proficiency tests. So we are affected by two kinds of biases. We have undercoverage because it includes teachers that are not in unions. And we also have non-response bias because only 32% of the people responded. And those are probably the people that feel very violently one way or the other about national proficiency tests. Number 15, consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason for randomly assigning treatment levels, spraying or not spraying, to the experimental units, farms? Well, remember, why do we use random assignment? It is to average out the confounding effects that we don't know about or the ones we can't control for. So it will average out all other uncontrolled factors such as soil fertility so that they are not confounded with the treatments.